All right, so I'm Shailendra Mathur. I'm the Vice President of Architecture for Avid. So there's a big debate going on in the media industry. I'm sure a lot of other industries that are transitioning to the cloud are facing the same problems. And that debate is about, should we take the infrastructure that's deployed today in a lift and shift approach to the cloud, or do we refactor everything into a cloud-native microservices-based architecture? So I'll give you the answer. You don't have to wait till the end. You need both. Right. And the rest of the talk is just justifying why. Thank you. Now you can go back to sleep. So basically the topics, actually, sorry, is the screen up here? It's scrambled up here. Yeah, it'll avoid a net cramp. Great, thanks. All right, so what I'll do is first kind of pose the problem statement of what is the current media production infrastructure that we're talking about. Then I'm also going to go through a few definitions of cloud. You guys think you know what cloud is, but wait till you talk to some of the customers that we're talking with, and the different definitions come out. But we got to pay attention, very close attention to that, because these are the customers who are moving. So what they need is what they will get. I'll go to the lift and shift versus microservices-based approach. What does it imply? And then just talk about the Avid Media Central platform and how it actually hooks all of these things together. So there are multiple domains that we can talk about. We've talked about VFX rendering. We've talked about 3D animation. I'm focusing on the broadcast side in this presentation, just as a frame of reference, especially when you look at a lot of productions that happen on the broadcast side. Especially news production, sports production, it brings in so many different things, so many different aspects that once you can kind of solve that problem, the other domains kind of just fall out of it. And of course, you can have distribution. That's an area of focus for a lot of people. I'm going to be focusing on the in-studio post, the infrastructure required there. So let's take a look at the existing production workflows and infrastructure. First of all, let's start off with storage. Right? It's the place where everything is going to go. That's where all of your media acquisition, editing, collaborative editing, and your final publishing is going to happen. And the existing storage are also tiered, right? So it's not just one type of storage. You have parking storage, archive storage, the real-time collaborative storage. So that kind of forms part of the hub of the media production. Then you have ingest that actually brings material into the storage. So what does ingest mean? So here I'm trying to cover both the hardware infrastructure as well what it implies in terms of compute and also in terms of the network, so that when we look forward onto what are we transitioning over, these form the problem statements. So here, ingest can be from workstations itself, or it can be through hardware appliances or software appliances. It's typically CPU intensive, but also on premises you have SDI infrastructure moving now to IP as well. So these are the baseband signals coming in. So that's the type of infrastructure problem statement that we're talking about here. Then you got all the creative tools. So you've got everything ingested. Now you have to go through all the different creative tools. The creative tools could be graphics authoring, video editing, audio production. These are all the tools that we're talking about. And especially when we talk about the client applications, then you also have to talk about the different controllers, everything all the stuff that editors, mixers, these guys are used to. So these are all the client workstations. So, and the applications can be thick clients, so your traditional applications, or they can be web-based client. And of course, for asset management, web-based clients are pretty common. But then within Avid, we have editing capabilities in a web-based browser environment, as well as the thick application Media Composer that actually can be used for editing as well. So you have thick and web clients here, typically working off workstations. So there, what's important in terms of compute, Of course, CPU rules over there because of the number of FX, number of codecs that you need to support. GPUs, especially for graphics authoring, but also very importantly for display. And especially now, as we're moving into more VDI-based environment, the GPUs in all of this whole infrastructure, transitioning that over to the cloud is becoming more and more important. And of course, we're talking specialized compute as well. So you have FPGA-based hardware accelerators, even on the client side. You have DSP processors that are for example, on the Pro Tools side. So this is what forms the whole infrastructure piece that needs to transition over. Then you have publishing or broadcast. Similar to the ingest side, these can be hardware appliances, software appliances, workstations from which you're actually doing file exports. Traditionally, the connectivity is SDI again, or now going to IP as well. Unlike the ingest side, at least on the publishing side or the egress side or broadcast side, you do have to add on the graphics pieces as well. So I mean, any branding will go through these dedicated hardware appliances for now. Then you have asset management, which is managing all of this media, the metadata, everything that's coming around, whether it's from the ingest process and logging processes, the editorial processes, as well as distribution and storing some of that information, tracking all of that information. This typically requires general purpose compute and some databases, some of them custom. So basically, this is what we're talking about in terms of the problem statement as we talk about moving to the cloud. And hopefully you can see where lift and shift actually becomes important for a lot of the broadcast customers because they have trained artists, they have infrastructure set up for this, and there's a lot invested. There's hundreds, if not more, years of development invested in some of these applications. And of course, I'm not just talking about Avid applications. These are all the different applications that are around. So let's jump to that interpretation of cloud in the media industry. And I'd be interested to hear if the same interpretations do exist in other industries as well. But whenever we've been talking with the customers, the first frame of reference is, of course, the machine room. What's happening in the machine room? What did you put over there? You have your workstations. You have your servers actually running in the machine rooms. You have SDI connectivity in there. Usually bare metal servers running over there. Network-based storage. This is where you can connect up your IP, SDI or IP devices as well. That's the frame of reference. But guess what? The term cloud actually applies there too. Because some of the folks who are actually doing multi-zone environments, connecting up multiple bare metal servers, they have been considering this to be a form of cloud as well. There's a NIST definition of cloud, which doesn't match that. But again, the media industry has been looking at that as some of the cloud, part of the cloud workflows. But then what happens when you go from the machine room and want to start virtualizing, want to start centralizing your infrastructure? So you're moving from your machine rooms, which a single department might have, into a data center, which may still be on premises, but then serving multiple departments. And that's where the virtualization piece first starts kicking. And of course, virtualization can happen in the machine room as well, but it is actually in the data center as it becomes essential. But suddenly what happens is that you can't run SDI cables everywhere. So IP becomes almost a necessity for any network transport. A natural transition from the data center is what we're calling on-premises cloud. It just means it's the same data center, but now the software stack changes over to be a much more of a cloud-based software stack. So Azure, the Azure stack is an example of that. Some of the VMware stuff that's coming out, that's being used, those are also examples of how some cloud provisioning is happening on those data centers. So you can see a slow trend towards basically going all the way to the public cloud. So this is sort of on-premises. So far, you can assume a lot of this infrastructure is even owned by the customer. Then here's an interesting one. And this is the name that I'm wondering if there's a better name for this. A local cloud. What's a local cloud? It just means it's geographically local. So this may be provisioned by a public cloud provider, but just the fact that you have needs for high speed, low latency, and high bandwidth connections means geographically local clouds can be set up. So it's an extension of what you're doing on the data center, but you no longer own it. You actually, a hosting provider owns it. So that's the local cloud concept. And it may be actually single tenant or multi-tenant. And that's where the colos come in, where you can start putting in your edge devices, some of the storages there as well. Then we move into into familiar territory of what a private cloud and a public cloud is. And these are just extensions of these. So private cloud, literally now you're going to a public cloud, a cloud provider, but dedicated to a single customer, and then going all the way to the public cloud. So these are all the definitions. Depending on which customers we're talking to, when they say cloud, we have to ask, what do they mean? And it's one or more of these that comes out. Of course, everybody's sort of headed towards the public cloud type of environment, but this is the reality for now in these transition phases. Right, so how do we take all of those, that environment that I showed you on premises for the post-production workflows, how is that relevant to these type of hosting models? Well, you only have 3 methods by which you can bring those forward. First of all, the reference is the bare metal. What's in a bare metal environment? You have compute, network, storage. You have the, because it's a local, you have the flexibility of just connecting up a display even. You have IP or SDI connectivity interfaces, and you can afford to have controllers. So even in a geographically local, in a LAN environment, for example, some of the Yukon-based controllers will work as well. And typically, these software appliances, if they're working as an appliance, single host OS, multiple apps running on it, or a single server, a software server running on it, web clients or thick clients working on it. The second model, whether it's on-prem data center or in the public cloud, is just VM. So this is the one that's associated. Whenever we say lift and shift, that's what that means, right? You're just taking your current software appliances, moving them over to a virtualized environment using your favorite virtualization technique. So so compute, network, storage, VDI. So instead of directly connected displays, you have VDI. And there was a mention of PC over IP, pretty popular there. Some of the IP interfaces come in rather than SDI. What happens with the software services? Well, basically they get isolated within their own VM layers. So each VM has its own OS running, and then the application and the bins and libraries are actually running in that environment. And the web client and thick clients actually work through that in a client-server architecture. So there is a method with virtualization to move over into this into any virtualized data center or in the cloud environment. Some of this is probably very familiar to you, but I just want to go through the whole patterns. Then comes the question, well, how about I take my apps, bins, libraries, and why does it have to run within each guest OS? Because now each time I spin up a VM, I had to have a single OS dedicated to each, and that's where microservices come in. And the concept of containers come in. And that's what is very popular and the most flexible and cost-effective in a public cloud or any cloud environment. So what does that mean? You don't have to now dedicate a single OS per VM. You can just take parts of the OS and run it within the container that's hosting your microservice, and associated with very fast spin-up, spin-downs. So this is what's, so Docker is one of the containerization techniques used over there. But just to get to that level, you either have to start fresh to develop microservices, or you have to refactor a lot of your existing software appliances to go into the microservices architecture. And that takes time and money. So this is where, these are the different hosting patterns that can be used. So let's look at a little bit more at why microservices. So we had talked about the fact that today, when you're building a software appliance, so a transcode service, as an example, a transcode service running as a software appliance needs to support multiple formats because you don't know what's being thrown at it. So these are formats and codecs that are for ingest as well as destination formats. So you build it as a multi-function software appliance. Apart from the codecs, you also have other like transformation techniques, spatial transformations, color transformations. All of these things are built in here. So basically, that would be a multi-function software appliance. The other thing you do is instead of multi-function single appliance, you can split out all of these functions, and that's where the refactoring comes in, so that every single format has its own, it runs in its own service and can run it as a microservice and in its own container. So that's basically what the microservices approach is. That's what the refactoring implied here. So if you have these three frameworks, the hosting frameworks, how do these services communicate with each other? How do you host them? Who provides that service framework? Who provides the messaging framework? And that's what I'm going to concentrate on here, which is what is that messaging framework primarily? So typically, in a bare metal environment, if you have multiple software appliances running, you have some job management services, some workflow engines that know how to actually talk to each one of them. And usually, it's the application provider who provides that communication fabric. Same thing when we go to a VM in a lift and shift approach, you continue that same pattern of the communication fabric run by an application provider. The hosting of the VMs can actually now go to the infrastructure provider as well, but the communication fabric still typically remains with the application provider. When you go to the cloud provider and when you deal with microservices, you have choices. So a cloud-native implementation would mean that your microservices are hosted and the messages and events that they're executing are typically controlled by the cloud provider. So there are different implementation. You have Google functions, the Lambda functions under AWS, or Azure Fabric. These are all examples of methods of communication, hosting these microservices and communicating between them. So some of the media industries, when they're actually moving into this microservices architecture, they're typically they're applying, just for quick bring up, they're actually using some of the cloud provider based the communication fabric. That also implies a bit of vendor lock-in, right? So if you just wanted to stay on Google, AWS, Azure, that's fine. If you wanted to now support multiple hosting models, that's where you need a communication fabric that goes across. A service hosting as well as a communication fabric that goes across. And that responsibility comes back to an application provider and not just to the cloud provider. And that's what we'll talk about next, which is what is that communication fabric here? So, basically, what I'm going to talk about is the message bus. So that's one of the mechanisms for communicating between services. And you'll see how this message bus architecture allows you to process events from a hardware appliance, software appliance, which is virtualized, all the way to the microservices side. And I'll put it in very simple terms of why do you need it? Well, typically, any type of service, when you're talking to each other, needs to know the APIs. So whether it's a transcode service, then a publishing service, each one of them then needs to know what the API is. So a typical communication protocol would involve point-to-point communication. So you know the REST API for one, you call it, then so basically there are multiple connections that you need to form. What that means is that as soon as you bring up a new service, it needs to know about the other ones as well. So again, so the dependency chains multiply quite a bit. If you're just doing simple stuff, one-to-one relationships, that's easy enough. But as you scale your service framework, the services that you're deploying, that fabric grows quite a bit. So this is where the whole idea of the message bus comes in, which is based on a publish-subscribe model. So any service, any media service that you're bringing up, it publishes the type of messages that it'll actually emit, and then any other service that's coming onto the message bus subscribes to those. So any events, so you could typically have event libraries that you can listen to. So now what you're listening to is the message bus. You're subscribing to the message bus versus being aware of the other services. Advantage of that is as soon as you add a new service, again, you're not making multiple connections, but actually a single connection to the message bus and subscribing to the events that you're interested in. What's even cool about this is that if service 4 over there is listening to a particular event, and service 5 comes up and wants to listen to exactly the same event but just do something different, that's possible as well. So for example, this could be a chain of like transcode QC publish, and say number 4 is a publishing service. Number 5 could be receiving the same event from the step before and saying, oh, I want to, when the, say a QC process in number 3 is finished, I want to send out a Slack message. So how does that tie things together? You have, on the left-hand side, the bare metal environment. You have the virtualized environment, the cloud-native environment. And in the bare metal environment, I'm just talking about a software appliance, but it could be a hardware appliance over there. In the VM, again, the same software appliance in a VM, sitting in a VM. And then you have microservices, those in the cloud-native environment. You can actually run some of these microservices also in a virtualized environment as well. What you do is you take your message bus, and you have an implementation for each one of these. So on the bare metal side, you have an implementation. You have virtualized data in your virtualized environment. You have the same message bus and the cloud environment. So it becomes a federated message bus. You can actually pass messages from one to another. So now suddenly you have your machine room with services communicating with services that are running in your data center, communicating with microservices that you might have deployed on the public cloud. So that becomes one of the key aspects of this messaging platform. Let's just step through the media ingest and processing example, where an ingest hardware appliance or a software appliance may be sitting maybe on bare metal, writing to storage. As soon as that's finished, over the federated bus, you have an event going over to your data center where you might have a transcode software appliance sitting there, picking up that media, doing a transcode, and again, this is one of those multifunction software appliances. The transcode service, once it finishes, issues an event to the transfer service. At that point, that can be just a microservice. You spin it up just for the compute time that you need, even in the virtualized data center, and then that triggers a cloud upload. Once the media makes it into the cloud, again, other microservices that you've deployed and that's working through this federated message bus will kick into gear. One of them might be a quick QC process, and then the last one could be that Slack microservice that I talked about, just publishing what's happening, with the result of the QC. So just taking it one step further, I talked about the services, but what about the APIs? I talked about the whole client. All these clients need to talk to these services as well. How do they talk to the message bus? Well, that's where you have a set of APIs, and we do publish a whole set of APIs on these services within Avid. And so the clients, whether these are thick clients or thin clients, they can actually talk to those the RESTful APIs, which gets converted into message bus commands and events as well. So in fact, last year we even showed, so this is not just Avid applications through the same APIs, we actually showed Adobe Premiere working off the same backends. So it is actually a scalable framework and quite open in its APIs. And of course you need to do this in each environment, you need the service management side, you need the connectivity toolkit and API management, you need the service execution framework, which could be as simple as just passing events, or it could be as complicated or complex and rich as a full workflow engine that's actually running there. The user admin and config become very important. Security becomes inherent in this architecture because every single call is authenticated, whether it's an external call or even internal call, and especially when you're doing federated communication, you need to authenticate between all of these realms. So, just summarizing, if you had anything to take away, these are the 3 takeaways. In the media industry, be careful when you're asking, hey, do you want to go cloud? Because the answer may be yes, but you still may not know exactly what they mean. So we have to, when we're talking about cloud, we need to come up with a consistent interpretation of what some of the folks are asking for. And yes, people need both lift and shift, as well as the flexibility of the cloud-native microservices architecture. And that's where the Avid Media Central framework that we've developed actually goes across all of these environments to bridge all of them. That's my talk. Thank you.